My name's Andrew Dick, and I'm the director of UCL's Institute of Ophthalmology. And there are lots of enjoyable bits to this job. One of them, by far, is when people have progressed in their careers due to the fact that they are just sheerly and utterly wonderful, and get conferred professorships. And then the next, and then I'm able to let people know, and that's always very enjoyable. And then the next exciting thing is obviously having an inaugural lecture, which is just such a wonderful, entertaining, not putting you under any pressure, but entertaining time that really gives credit and value to everything that you have been doing, and for us to be able to listen and celebrate with you what a marvelous achievement is to be conferred professorship. And certainly for us, pride at being at UCL and the Institute of Ophthalmology. So for those, and I'm sure you're here because you all know, but it's always a delight to say, who is Professor Annegret Dahlmann Noor? Who is she? Well, of course, everyone will know because they know her well, but she is now Professor of Paediatric Ophthalmology at UCL and consultant, as we know, at Paediatric Ophthalmologist at Moorfields Eye Hospital, and also a fellowship holder through the National Institute for Health Research. So quite an established pedigree. What I love is about the focus on childhood eye conditions, but particularly the spread. And one of very few people outside Asia that actually decides to really get into myopia, a pandemic occurring, essential to find solutions to care for the people who are currently suffering. But not only that, in all aspects of amblyopia and developmental vision disorders. So it's quite an accolade that you're able to combine that with looking at population health, clinical trials, and also with the relationship with UCL into laboratory investigation. And so it's quite a portfolio that your passion drives to involve children and families and everybody within that research, development is construction, the way you do it together to answer questions. And your co-founding, of course, of the Young People's Advisory Group, which is just such an amazing community that enables exactly what we're looking for, to build in people that are able to support us in our research. One, two, help direct us in our research, and then co-create what we do together. So quite a remarkable bit. But you seem to do an awful lot. And I'm always so amazed how you lead services and have time to do all of this and write grants and share them with me, which is always a delight to read. But also prolifically publish and being able to be on stage to promulgate your findings and promote the work you do of everybody that in this field. So those who don't know her, I didn't realize medical training in both France and Germany. I didn't realize that bit. And then specialized as an ophthalmologist across several leading hospitals in the UK. We are very glad she's here in our community at both the Institute and Moorfields. I'm very glad she'll be leading a lot of the way in our new centre at St Pancras, but not just about the new centre, about engaging in the community. And I think one of the most things I've been so impressed, not that that should be important, but what is very impressive is your community work and the way you've spread research from looking from a laboratory setting to an experimental medicine setting, but also looking at it within the community where it really matters to make a difference. So there are numerous qualifications. I see you qualified from school, which is always excellent. No, seriously, you've got a whole list of wonderful, but the most recent being the NIHR Senior Clinical and Practitioner Award. Huge congratulations on that. So I'm going to leave us to all together introduce Professor Dahlmann Noor for her inaugural lecture, which we are all really looking forward to. Thank you so much for delivering this today. Thank you.
Thank you very much for coming today. Although it's 5 o'clock on a Wednesday afternoon, it's the peak holiday season. And lots of our colleagues are already enjoying their summer holiday. So thank you for hanging on in there and giving up an hour of your time today. There will be drinks afterwards to compensate. And it makes me really happy to see all my wonderful colleagues here, both from UCL and from Moorfields and from the Young Persons Advisory Group for Research and from Bedford. And my family is here, my own family who live with me in Bedford, and my brother and his daughter have come over from Germany as well. So it's fantastic. Thank you so much. Whilst it's wonderful, it's also slightly daunting because not everybody here would know or would have been to an inaugural lecture. If I'm honest, it's my first one too. I haven't been to one either. And the reason is they're always on Wednesday afternoon, and I work in Bedford in the hospital there on Wednesdays. So I will try my best to make it entertaining, tell you the story of my life, because I think that is what an inaugural lecture is supposed to be about. So it's about how I got to where I am now. So I'm a children's eye doctor, and I like to think that I'm a translational researcher. I've spent quite a bit of time over the years trying to figure out why some children get eye diseases and why some children and not others, trying to develop better treatments and trying to make sure that those children who will benefit most from those innovations actually have access to them. So when I was thinking about the title for today's lecture, it was actually fairly easy. I could sum it up in 4 words. Every child's vision matters. Now, you might think that's utterly obvious, but sadly, today, that is not the case for every child. Not every child has got access to good eye care. And the reason why vision matters in children is that it's about education, it's about confidence, it's about attainment, it's about future life chances. The pediatric service is joining. So it is really about giving children the best chances in life. That is why vision matters for children. So what I want to cover today are 3 questions in this talk, it being an inaugural lecture. How did you become the person you are? I don't just want to talk about the professional, but about the person that I became. Why do you do the work you do? And what do you hope to leave behind? My journey started in Bochum in Germany. I was a single child, top right, until my little brother came along 6 years later, Alfred. My dad, bottom right, was a technical draftsman, and my mum, bottom left, as was usual at the time, had given up her job as a secretary when I was born. Bochum is in the Ruhr area of Germany, once one of Europe's great industrial regions. There were coal mines, top center, steelworks, top right, and working class communities built on resilience, solidarity, and mutual support. And that mattered because when I was a medical student at top left, the Ruhr University, I still met men who had worked all their life in the mines until they closed. And when they closed, they retrained as nurses and healthcare assistants. So I met them in the hospital. And they had a culture where people looked after one another. There was a very deeply held belief that nobody should be left behind. And I think that did influence my development as well. I don't think I appreciated at the time how much those values would influence my own career. Only much later, when I became a pediatric ophthalmologist, did I begin to realize how profoundly children's opportunities are influenced by where they grow up, the environment they live in, and whether they can access healthcare. There is another reason why going to university in Bochum, I'm on the girl on the screen there in front of the X-ray screen on the left, my much younger years. There's another reason why going to university in Bochum changed my life's course. It was there that I met for the first time the person who first introduced me to research, Professor Monika von Düring. That's her, my great idol. Like many medical schools in Germany, ours encouraged students to undertake research projects alongside our medical studies. I joined Professor von Düring's lab in my first year. For the next 3 years, I spent my evenings, weekends, and holidays in her laboratory. I learned histochemistry, immunolabeling, light microscopy, and electron microscopy. I absolutely loved it. Our project focused on the innervation of the endolymphatic sac and duct in the inner ear. Now, I don't expect anybody here to rush home tonight and read up all about the innervation of the endolymphatic sac. But the project isn't really the point. The point is the excitement. The excitement that I felt when I was looking down those microscopes and I saw something that nobody else had ever seen before, like top left, that cell reaching out into that lumen, right? What on earth? What type of cell is that? Or those crystals at the bottom. Now, what are crystals doing in this blind end structure? Now, it looked like the dustbin of the inner ear. And then when I did the 3D reconstruction manually at the time, that's at the top right, slice by slice, you draw the outlines. It became obvious that all the blood vessels and nerves were on one side of the endolymphatic sac, and on the other side, barely anything, right? So all these things were really, really exciting moments for me at the time, even though it might not seem as exciting to you at the moment. And what I saw there was that you suddenly realize that textbooks cannot tell you the full story. Textbooks are not the end of knowledge. They are just the point where the knowledge has got to at that time. And research starts beyond the last page of the textbooks. And you can contribute to this knowledge because you can tell other people what you found. So this was my first publication. So again, I'm not sure whether it had a high impact, right? But it was my first publication and a very important milestone. So research had opened one door for me and another one was soon to follow. I had grown up learning German and French because my parents put me in a bilingual school. The reason was that they didn't speak any other languages, but they were both born in World War II. And for them, one of the core values of their generation was that no war should ever start in Europe again. And for them, it was crystal clear that understanding each other's culture and speaking each other's language was absolutely paramount to that. So I had gone through this whole French-speaking school, come out with a diploma that gave me access to French universities. And then my medical school started an exchange program with the Université Louis Pasteur in Strasbourg. So I quickly raised my hand and I couldn't resist. So I went to Strasbourg for 2 years. And that was a milestone too, partly because I was exposed to a different healthcare system, but partly because I also added another chapter to my thesis. So up to this point, my work was firmly rooted in neuroanatomy. But when I was there, I couldn't find anything equivalent. But I spoke to the Professor Gentin, an ENT doctor, and he gave me an audit to do. So we did a clinical review of his results of decompression surgery on the endolymphatic sac in people with Meniere's disease. So maybe at the time I didn't realize how fundamental that was because I thought I was just adding another chapter to my thesis. But actually, I did something that was completely new to me. I linked up something I had seen in the lab with something in clinical practice. So I started to form the bridge between those two worlds. And it gave me an idea of what sort of researcher and doctor I wanted to be. But first I had to go back to my own medical school in Bochum to complete my degree. And during that last year at medical school, my colleagues said I should go to the UK for at least a year for my postgraduate training, because the postgraduate training in the UK had the reputation of being a lot more hands-on, and they thought that would suit me very well. So I applied, I got a job. I spent 18 months in Royal Oldham Hospital, Monklands Hospital in Airdrie and Edinburgh. And I learned about the basics of medicine and surgery. Now, the plan at that time was very easy. Go to Britain, learn as much as you can, and go home, right? But as we're here today, you've probably realized that it didn't quite go that way. So after during those 18 months, I still had no idea that I wanted to become an ophthalmologist originally. But what happened during that time, and I think it happened in the middle, was by pure chance, I picked up a textbook. Sorry, I've lost my slide here. I picked up Adler's Physiology of the Eye. And I remember when I opened that book, I thought, how comes nobody ever told me that all this exists? So in that book, I found everything that I was passionate about. There was neuroscience, physiology, vision, perception, development, clinical medicine. So I actually came to ophthalmology through physiology, not because of surgery. It really, really inspired me. So I had found my subject. And my colleagues at the time were really, really supportive, but they also brought me down to earth very quickly. They said, oh, well, ophthalmology is one of the most competitive specialties in the UK. If you want a job in ophthalmology, a training post, you need to pass part 1 of the fellowship examination of the Royal College of Ophthalmologists first. So I did what everybody did at the time. I bought a huge pile of textbooks and I spent my evenings in the library and in my flat reading and studying. I took the exam and I passed it. And then armed with that certificate and a lot of enthusiasm and no experience whatsoever, I started applying for my first job in ophthalmology. And now we go to the slide that you've all already seen, because where I landed a job was in York. And what I want to say about York to start with is I had great inspiration from Bob Taylor. There are in every profession people who just quietly do their job, but do it so, so well. And they train the next generation and the generation after that. So I was a completely inexperienced senior house officer in ophthalmology. I had passed my exam, but I had no idea about eye diseases. And I had no idea about how to assess a child. And my first rotation, my first placement was in pediatric ophthalmology with Bob. And Bob not only taught me how to examine a child, he also taught me how to see the whole family. That the child is not the only one who's our patient in the room, but how to speak to parents, how to ask the right questions. And when it comes to examining children, particularly 2-year-olds, to just focus on the most important question. You might only get one glimpse, and that glimpse will matter. So all that I learned from Bob. And then after a year, I got a job on the Yorkshire rotation for trainees in ophthalmology, and I moved to Leeds, to the Leeds General Infirmary. And there I met another exceptional teacher in pediatric ophthalmology, Rob Doran. And I think between Rob and Bob, they have probably trained dozens of pediatric ophthalmologists in this country. So then what happened was that I passed my part 2 of the fellowship examination of the Royal College of Ophthalmologists. So I was now eligible to apply for a job as a higher surgical trainee. And I got that in Birmingham. So I moved to the West Midlands. And there I quite enjoyed learning all the more practical aspects and surgical aspects of our craft. But the research itch came back. I found that I had covered all the knowledge bits, I thought, and there were still many unanswered questions and the textbooks couldn't answer them. And I was really wanting to do research again. But as a clinical trainee, your options are limited because you're so busy. So usually you write clinical audits, case reports, and review articles. And one of the questions that fascinated me at the time was that of wound healing. So every surgeon has seen that some wounds heal well, others don't heal well, and yet others don't stop healing. They are just so exuberant, they make scars. So why is that? And in ophthalmology and eye surgery, that really matters. So why do some people have these terrible scars and others don't? And are the cells maybe driving that? Which cells cause that scarring? So there was a person whose work I had read a lot about, and that's Sir Professor Peng Ko, who many of you will know. So I made an appointment. I asked him whether I could maybe do a PhD project with him. And something else had just happened. He had just recruited an outstanding scientist from the US to come to the Institute of Ophthalmology, Maryse Bailly. Now, Maryse is a cancer researcher, and she is studying how cells move and what the impact is of the cells moving around. So that is obviously relevant for cancer, but she was going to bring that knowledge to the question of wound healing and scarring. So we sat down together, we developed a project together about fibroblasts. Now, most people in this room have probably never thought about fibroblasts, and by that time, until that time, I hadn't either. But they are really, really quite interesting cells. They hold everything together. And I often thought about them as sort of tug and war cells. So if you think a person is pulling on a rope, right, one single person can't move much. But if hundreds or thousands of people pull on the rope, they can move an enormous load. So that was what we wanted to study, how these cells, the fibroblasts, interact with the surrounding collagen and tissue, and whether that had something, whether that could in part explain how scars form. So we built that amazing machine at the top there. The cells are cast into that pink gel, and then we can look at them under the microscope, and they are hooked onto a machine that can measure the force that these tens of thousands of cells build up together. And the output of that are your microscopy pictures and this force line. So you can measure the force that they exert. And at the beginning, it's quite low because they're not well suspended yet in their solution. And then as they spread out, they start to build up this tension. And we looked at cells from different parts of the eye, from the front part of the eye, the cornea, and from the tough white outer shell of the eye, the sclera. And we found they each had a different level of tension where they settled, where they were happy, the sort of tensional homeostasis. And that was different for the corneal cells and for the scleral cells. So this was my PhD research training fellowship that the Wellcome Trust kindly funded. And it also led to a publication. And I really, really enjoyed doing that work in the lab, I have to say. If you're wondering why I was doing a second doctorate when I already had one from Germany, the answer is actually quite simple. The British universities didn't accept my German doctorate because I hadn't done it, or they are not done as a full-time study over 3 years, or as a slightly longer over 6 years or whatever. They said just doing it alongside medical school isn't good enough. So if I wanted to have an academic career in the UK, I needed to do a proper PhD. But as I say, well, it all went well. I got the funding. I spent 3 years in the lab, and I really, really had a good time there. During those 3 years, Nadim and I got married. See the photos on the left, very much youth pictures. And Hamza joined the family. And because that is my family photo slide, I've also added in the slide from when Jasmine and Rian completed our family a few years later. So then I had to go back and complete my clinical training. And I traveled east. I should just go back one, because in the first year of my being back in clinical training, I completed my thesis. I wrote up my thesis and I defended it. That's why Hamza and Nadim are on that picture as well. We were a very happy family at that stage already. So then I had moved to East Anglia. So I was in the West Midlands before I came to research, and then I went to East Anglia because Nadim was working there. And guess what happened? I found pediatric ophthalmology again, a third inspirational trainer. This is Tony Vivian. And he worked at West Suffolk Hospital and Addenbrooke's Hospital in Cambridge. And he has also trained a huge number of pediatric ophthalmologists in this country. And I worked with him for nearly 2 years. And I learned about how to manage complex strabismus and how to speak to parents and how to assess children. And I also had the chance to do some field work. We went into schools with a brand new autorefractor, the Plus Optics, and checked children's vision. And really, we checked how well the new autorefractor was performing. So that was a good time. And then that was it. So I was now a certified specialist in pediatric ophthalmology. That was the end of the training road. The problem was that I didn't really want to be a full-time clinical consultant. So I went back to Peng and asked whether there might be any chance of going back to the lab, at least part-time. And as luck would have it, he had funding for a postdoctoral student to work on optic nerve regeneration. And I could work in his lab again. So that went on for about 2 years. And then during that time, we had moved to Bedford. And I had found out that the eye clinic at Bedford Hospital belongs to the Moorfields network. So I had knocked on the door and said, well, sooner or later, I need to start working as a doctor. So do you maybe need a pediatric ophthalmologist? And I met Mel Hingorani. And Mel Hingorani was leading the pediatric eye service there, and she was already looking for a second consultant. So she wrote a business case. And at the same time, the Moorfields NIHR Biomedical Research Center was thinking of starting a pediatric research program and was putting together a business case for a pediatric clinical trials lead. So that was just fantastic, right? There was a part-time clinical job in Bedford where we live, and the part-time job at Moorfields that I thought I would really enjoy, pediatric clinical trials lead. And when I got the job, I was so happy. One of the best aspects of my work at the BRC has been that we could develop a place to run clinical trials with children. This is a very unique place because we have got research orthoptists, research optometrists, research nurses, imaging technicians, and clinicians all working together to bring research to children. It's a bit like an eye clinic where we have got a fantastic multidisciplinary team as well. And we can also run this type of research in other locations, such as my eye clinic in Bedford. And we did, because often those trials run better in the network sites because we've got more children there who are eligible to take part in those trials. One of those trials was the BALANCE trial. Vijay will be smiling because that was really hard. So what happened was that Steve Dakin here at the Institute of Ophthalmology had developed a new treatment approach for amblyopia or lazy eye. It's based on a 3D stimulation. If you want children, watch movies, but the input from the two eyes is balanced. And the way that happens is that the vision, the input from one eye, from the stronger eye, is blurred to the same level as the child sees the things blurred with the weaker eye. So it balances the input at the level of the brain. And that makes the brain take more notice and more interest in the signals coming from the weaker eye. So if you keep that up and you watch your 3D movie for an hour a day, then over time, this imbalance that makes one eye stronger, one eye weaker starts to resolve, and the cells in the brain make new connections and the vision improves in the weaker eye. Now, the first generation of that technology that they developed was two huge PCs and 3D glasses that were held on the face with skiing goggles. And Steve's PhD at the time, Manuela, had to go to all the children's homes to set up that equipment. But excitingly, it worked. So we got funding from Action for Medical Research for Children and took a leap. So we transferred the technology to a games console, the Nintendo 3DS, and they could watch the 3D movies on that device at home without needing much space. And over 16 weeks, so 4 months, we found that indeed the vision improved, the treatment worked. It worked as well as patching, which is our standard treatment. Not better, but as good as patching, as well as patching. So that was quite significant. But the other thing we learned, I wanted to mention, is that we thought they would just love it. It's so much better than patching, right? But when we spoke to parents and children, parents actually found it quite hard to find an hour a day where the kids could just sit down and watch a movie. And for the kids, although Stephen had built up this huge library of movies that they could watch, they started to find it a little bit repetitive. And the same theme came up recently, a couple of years ago, when we ran a trial for new myopia control treatment in the clinical research facility here. You can see, again, VR headset. Now, the treatment mechanism here is that you shine a blue light at the optic nerve head whilst the child is playing this VR headset game for half an hour a day. And to the researchers' big surprise, most of the children used the equipment for about half of the time that had been recommended in the first 6 months and about a quarter of the recommended time in the next 6 months. But the saving grace was that in those who used it a lot, or rather the more they used it over this period, the better the treatment response. So in myopia, the eye grows longer. And what we saw was that those children who used the device a lot had less lengthening of the eyeball over 6 and 12 months. So this was a pilot study, and it will lead to further investigations. And now you've already mentioned myopia. So the other myopia, we have by now been assigned for about 4 myopia treatment trials with low concentration atropine, which is very much used in other countries, but because there was no evidence base in the UK, we were lagging behind a little bit. So this CHUMP UK trial was funded by the NIHR, the National Institute for Health Research, and the chief investigator was Augusto Azuara Blanco, and it's just been published. So it's very significant because this is the first clinical trial run with Western populations where the atropine 0.01% had a significant effect. And I think we in the clinical research facility were really proud that we completed this trial. We were the second biggest recruiting center in the UK, and I think it just is a testament to how far we have come with running clinical trials with children about eye and vision problems. So with listening to children and parents who took part in our research, there came a point where I realized that most of the questions we were asking in research were our questions. They came from the researchers, and they didn't really come from the children. So we started to wonder whether the children and the families should actually be involved in research design, because they could tell us what really matters. They could probably even tell us which treatments they would just politely leave in the corner. So we would not run into the problems with children actually using the treatment during trials and not wanting to take part in research. So whilst we had this vague idea that we wanted to involve and engage with children, I had no idea how to do that properly. So what I did is what I always do. I tried to find an expert, and I found an expert, but she said she needed money. So I then went to Moorfields Eye Charity, and Moorfields Eye Charity and Sun10 kindly gave me a startup grant to start the Young People's Advisory Group of Research for eye and vision research back in 2019. And we could hire Luca May Brady, the lady on the left, as our facilitator. She already had a huge track record in participatory research or activities with children, both in healthcare and in children's research. And Luca May joined us and taught all of us. She taught the children about research, and she taught me about how to interact with children and get their opinion. She brought creative methods. So top left, I'm sure everybody in this room has recognized this by now. That's a model of the retina, right? So if you didn't recognize it, the egg cups underneath, that's the RPE. And then you've got 3 colors of cone photoreceptors and the black one, which is a rod photoreceptor. And then they feed up to the amacrine cells in yellow, and they send their signals to the retinal ganglion cells in pink, and they all combine their axons into the optic nerve on the left. Right? So that is how we taught the anatomy of the retina. And the children, it was just amazing. The children learned everything about research, right? They learned about the life cycle of a research project, why ethics matter, how to design research protocols, how to analyze the data, and dissemination, how to make it easy to read for other children and parents. And they were not just sitting there nicely listening to researchers, right? You can see it's a very active discussion. They have got their questions and their opinion. And within a very short amount of time, they gave advice to researchers. So the format of the sessions is that first we learn something new, and then researchers come along and present their projects. And the IYPAC members, 3 of whom are here today, then give their advice how to make the research more relevant to children and parents, and how to make it more child-friendly and accessible for children of a particular age. Luca May has gone on to a full-time academic career, but our group has gone from strength to strength, with first VJ as facilitator and now Jack Miller, who has just completed her PhD on experience-based co-design of eye and vision research with children. Our group has joined national, international networks. We have just been to the International Children's Advisory Network conference in Dublin. And for the 2nd year running, our group has won a prize. The panel said they were just absolutely inspired by the sheer amount of outreach we have done, right? So you might think you as researchers do outreach. No, we do outreach as well. So the researchers come to us, but our group has also been to UCL 200 to engage with researchers to tell them how to do things, and has taken part in national and international meetings. So, whilst at the beginning, I had thought we would just ask the children to have a quick look at our information leaflets and the advertisement material, and maybe have a little bit of a word in the dissemination, it's gone completely. We have done all that, but we've done so much more. And it culminated in Luca May leading a self-evaluation of the group. So the kids interviewed each other. The kids interviewed the facilitators and the researchers that they had given advice to. And that was published as a paper as well. And the most important, I thought, learning point from there was that learning was a two-way process with both researchers and facilitators, so the adults, reflecting on how much they had learned from working with the YPAN. And all participants talked about the importance of impact, feeling that children and young people are making a difference to research. So I think that was mission accomplished. And that was then the time when another big step change happened in my career. I had tried for several years to get funding for myopia projects, for myopia research. And in 2024, the National Institute for Health Research gave me this big fellowship that's called a Senior Clinical and Practitioner Research Award. And then the Moorfields Biomedical Research Center did something else that was really, really good of that. They saved money on my research salary, and they said, why don't we split that and appoint 2 part-time research assistants for you? So Alicia and Megan joined. So suddenly we had a team. We call ourselves the Tiny Eye Tribe. Since today, we even have badges. And goodness me, over the past 2 years, we have done so much work. I'm going to tell you about that in a moment. So first about myopia, why myopia matters. Myopia matters because your eye grows too long, and that puts you at risk of developing sight-threatening complications later in life, such as retinal detachments, myopic macular degeneration, and glaucoma. So it can lead to severe problems. And what we are seeing now is that more children get myopia and get it at an earlier age, and it progresses faster. So by the time they become young adults, we now have more people with a severe degree of myopia who have a lifetime risk of those nasty complications. And because of that, it has suddenly become a public health challenge. In 2023, I had led the first UK consensus on how we should manage this problem of progressive myopia in children. We did a Delphi consensus with a large number of optometrists, some ophthalmologists, and some myopia researchers. We started with a literature review and interviews, and we developed 137 items that we would then vote on to find consensus. And I love that radar chart. I'm sorry, I like pretty pictures, right? So the radar chart in the middle shows you how over here 2 rounds of voting, the opinions converge. So the radar chart shows you the variability in voting as the interquartile range in voting in round 1 in blue. And then you can see it sort of gravitates towards the center in round 2 of voting. We came out with pretty useful things about when to start a treatment, how to monitor, and when to stop a treatment. But what we also discovered in the discussions is that we were all pretty disillusioned because only a small minority of children in the UK can actually access these new treatments to slow the progression of myopia because they're expensive and their parents can't afford them. So we still haven't repeated the consensus exercise because I said, well, what's the point in drawing up this beautiful diagram about what people should do when nobody has the money to afford those treatments? The main project of my NIHR fellowship was to develop a core outcome set for myopia clinical trials with children, the COSMIC project. So what does that mean? Now, when we do clinical trials, we want to find out which treatment works better than which other treatment. But the problem is that everybody can use different outcome measures. So we can't compare the results of one trial with another trial. And conventionally, nobody ever asks the children and the parents what they think about those treatments. So the feeling is that we should develop a core outcome set, a list of items that all clinical trials should report so we can compare them and we don't miss out on things that actually the parents and the children are interested in. So we worked with very diverse communities, including people in Tower Hamlets. That's a very poor part of London. This is the library in Tower Hamlets where we had our face-to-face meetings. We had online interviews with optometrists and myopia researchers and 2 ophthalmologists. And then we made a big list of possible items that could be included in the core outcome set. And then we ran another Delphi consensus, partly face-to-face and partly online, so that everybody could be heard and everybody could have a go at the vote. And then we did come out with 10 core outcomes. So this is now our recommendation of the items that every clinical trial of myopia should include. And whilst number 1 and 2, axial length and spectacle prescription, are always in there already, not many trials have reported number 6, quality of life, or number 8, satisfaction with the treatment. And that's just a question. For quality of life, we've got oodles of questionnaires, validated questionnaires. And for satisfaction with the treatment, it can just be, like a Likert scale. Was how good was this treatment for you and why? So we were very, very pleased with that project. And my mentors on this whole fellowship program are Augusto Azuara Blanco at the top, and here from UCL Comprehensive Clinical Trials Unit, Nick Fremantle. And they are absolute titans of clinical trials, so that they threw their weight behind the development of a core outcome set actually does mean a lot. Another part of my project was to find out how many children in the UK have myopia. And that turned out to be really tricky. I tried one thing after the other and it was all dead ends. And then by incredible luck, I got access to the NHS database of all spectacle prescriptions of children up to the age of 16 in England. And for those in full-time education, up to the age of 18. Now that's a huge amount of data, and I'm not a big data person, but I found Peter, who is here as well, who is a digital wizard, and he shares my passion for fairness in eye care. So Peter came on board and had a look at those big data. And we got support from Paul Foster and Anthony Kawaja about epidemiology or population health. So between the team, which also included Nick Fremantle and Maria Sifaki, we had a really good go at the data. And with ethics approval, early on, the NHS Business Services Authority, which holds that database, were feeling confident to give us the data anonymously. And they added in the index of multiple deprivation of where the children lived. So we did not only have the spectacle prescription, but also whether the children lived in a wealthy neighborhood or in a poor neighborhood. And then we added in satellite data about the green space, whether these children, depending on where they live, have a nice, safe green area around them at school or at home. Well, it was the home postcode. And we added in sunshine data to see whether these children actually are exposed to the healthy sunlight a good proportion of the year. Peter made that map on the left. And what you can see there, this is the map of England. So it's not the map of the whole of the UK. But the darkest areas are where the number of spectacle prescriptions for myopia is highest. So you can see immediately it's in the most poor, in the poorest neighborhoods, in the areas of greatest deprivation, and usually in large urban centers such as London, Birmingham, and Manchester. And the curves in the middle show you this index of deprivation from left to right, from poorest to wealthiest. And you can see that the risk of needing myopia glasses is highest in the children who live in the most deprived areas. And when you look in the bottom lines there, you can see that particularly for the young children, the differential is enormous. Children aged 5 to 9 in poor neighborhoods have got twice the risk of developing high myopia than the wealthier peers. And that's really unfair because these kids, by the age of 5 to 9, when they get high myopia, from that point on, they have a real risk of sight-threatening complications later in life. So that's something that should be tackled. And when it came to green space, I just look at the bars at the top there. One means no green space, and the vertical column means risk of myopia. So you can see that those with the least access to green space have the highest risk of myopia. So again, giving kids access to nice, safe green spaces might make a difference. It's something that we can tackle. So we've known for years that children not spending enough time outdoors has got something to do with myopia. And first of the things, and we don't know what exactly the problem is with being indoors, but one obvious one might be brightness. So I went round with colleagues from the UK Health Security Agency in schools in Bedford, where we live, and we just measured the brightness in the classrooms. And we were flabbergasted. Not only is there great variability between schools and between classrooms, but even in the same classroom, there is a big difference. So if you sit away from the window and the wall opposite, then a third of the time, the brightness where you are doesn't even meet the minimum building standards. That's how bad it is. So again, that's something that we could fix, right? Either change the windows and the lighting, or take the kids outside and teach them outside where it's brighter. Another project we ran this year with the Tiny Eye Tribe in particular, plus some more helping hands, was that we went to 6 schools in Wandsworth and we checked children's eyes there. Now, this is really, really spectacular. You can see our Uber, XL, Max, whatever taxi with all our boxes, because we built up a proper eye clinic where we went. So originally, I had just wanted to find out how many kids have myopia, right, in a part of London. But then the project became much bigger. And we got all the equipment on loan to do super duper scans of the front part of the eye, of the back part of the eye, to measure intraocular pressure. And we even got these super headsets. They are just new on the market. They measure pupil size and eye movements. So it was fantastic. We did that for 3 months, January to March, and over 1,000 children, age 8 to 18, took part. We are still early on with analyzing all the data, but a couple of things already stand out. One was that 8% of children can't see well. That's a huge number. So if you think, well, 12%, 8% is 12 children out of 100. If you've got 30 in a classroom, that means 2 to 3 children in that classroom cannot see properly what's on the whiteboard. And that will affect their education, attainment, future life chances. And of those children, 3/4 either didn't have glasses or were not wearing their glasses. So again, that's something that's so easy to fix. So why don't the parents take them to the optician? Maybe they don't even know that sight tests are free. And why do children not want to wear their glasses? Well, either because they're worried that they might break, or because there is still a stigma attached to children wearing glasses. So that was a number that I hadn't expected. I honestly thought until early this year there was no problem with children getting glasses in the UK. And now I know better. And we also found out that 23% of the kids had myopia. And at that age group, age 8 to 18, that's a lot higher than what's been previously reported. Now, possible reasons are that this was just one borough in central London, not a rural, very urban area, and lots of kids from poorer backgrounds. But still, 23% is quite a high number. But at least, we start having numbers. And the other door that opened as well during those 2 years is the red light story. So there have been publications that looking at a red laser light for 3 minutes twice a day can dramatically slow down the progression of myopia in children. But here in the UK, we think that looking at a laser light might be a touch risky. So we are really not keen on that treatment. So then I read that somebody here at the Institute of Ophthalmology, a professor called Glenn Jeffrey, had spent a lot of time looking at the biological effects of red LED lights. For example, he saved bees' lives. He saved the bees from death by pesticides. He put red LED lights in the beehives, and that recharges their mitochondria, gives them more energy, whereas the pesticides had damaged their mitochondria. So I went to Glenn and asked, could we do something for children? Could that work for children with myopia as well as the laser works? And Glenn knew somebody who had developed these wearable red light goggles. Now, they are not medical devices. They are made for aging people who want to give their retina an energy boost. But we took them and we gave them to some adults to try out for a day. And we found that they did have a biological effect. They increased the thickness of the choroid. That's the blood supply at the back of the eye. And that is something that also improves when children start taking either atropine or have these special myopia control glasses. So it is something that might be linked with slowing down myopia progression. The Sight Research UK gave us a small seed award to try the same thing with children. So children use these goggles twice a day for 3 months. And we did find a biological response. The choroid got thicker, and there were early signs that the myopia progression, so the lengthening of the eyeball, was slowing down. Right, so what do I hope to leave behind? I would say that the best bit that has come out of my NIHR fellowship is my team. Megan and Alicia are now so enthusiastic about research that they are writing their own PhD funding applications. May has joined us with a separate BRC development award, and Vijay has been working with myself and lots of other colleagues at the Institute and at Moorfields for many, many years, and is now building his life as a postgraduate and postdoctoral researcher and aiming for independence. So this year, everybody in our team had a presentation at ARVO. So Megan talked about our core outcome set. Alicia talked about the red light study with adults. May talked about sight tests, vision tests that children can do at home. And Vijay gave an update on our Cochrane review on amblyopia treatments. It is a broad portfolio. And then I thought about what could I tell you what I'm going to do over the next 5 years. And if all goes well, it will just be a straight continuation of what we have worked on over the past 2 years. So we will have clinical trials of new treatments to slow down myopia progression. We will continue to work on the question of green space and children having more time outdoors at school. And with Marisa's team, we will continue looking at the mechanisms underlying eye growth, myopia development, and hopefully identify new treatment targets. So for the clinical trials, the first one that we want to do is to do a trial with the myopia control glasses and the atropine 0.01% eye drops, but do it across the country and in community optometry practices, because that would tell us how well they work in the real world and what parents and children think about these treatments. We might also continue our work with the red light, but we will see about that. So those would be the 2 trials I would like to do over the next 5 years. I've been chasing funding for years to do a study about more time outdoors and more green space in schools. And just recently, one of these applications has been shortlisted for stage 2. That means in January, we've been invited to submit a full application where children would have more green space and more time outdoors in school. We've teamed up with the National Education Nature Park Initiative. They go around, green up schools and support the teachers on how to do more teaching activities outdoors. So I hope that with that project can really see the light of day at some stage over the next couple of years. And what's really exciting about this is that here myopia and eye health is just one outcome. And we are setting it up as a whole child health study. So there will be other people looking at children's health, mental health, well-being, and all of that. And I think that is exactly the right direction of travel, because myopia does not happen in isolation. It's a lifestyle problem. And the other study I'm really excited about is the adolescent health study. So that really interesting project will look at the physical and mental health of 100,000 children aged 8 to 18 over 10 years. And Paul Foster and I have been asked to lead the eye and vision theme for the adolescent health study. It's probably going to start up later this year. And when you look at what we have learned from the Wandsworth eye study with 1,000 children, imagine what we can learn from 100,000 children. And really exciting is that the children who take part in this study might already benefit from all the new things that the researchers will learn, because by the time they develop conditions in adulthood, there might be new innovative treatments for that. So I'm really, really hoping that this study will start soon. And the third door, of course, feels very special to me, because it takes me right back to the start of my research journey in the UK. Many years ago, Maurice and I were looking at ocular fibroblasts, and we would never have imagined that this many years later, we go back to scleral fibroblasts in particular, but through the lens of myopia. So today, Maurice and her team are developing sophisticated 3D culture models of the sclera and the choroid, so they can study the cell behavior in a sort of model natural environment. And Gary presented their progress at ARVO this year. So I love this project because for me, it brings my story full circle. To me, this is what translational research should be about, not the lab on one side and the patient on the other, but it's an ongoing conversation between cells, scientists, clinicians, and children. So what have I learned? I would sum it up as research begins with curiosity, research succeeds through collaboration, and research matters because really every child deserves the opportunity to see well, to develop, and to learn. And with that, I would like to say thank you to everybody who has been on this journey with me, both at work and at home. My husband Nadim, my son Hamza in his graduation outfit, so the next generation is ready, and my daughters Jasmine and Rian. Thank you.
Annegret, on behalf of all of us, that was the most beautiful oration. Thank you. It had the personal aspect, the journey, the very nice interpretation of translational medicine. I enjoyed that. But mostly the most unmodest way you sell what has been a very eventful career today, and very worthy and just of being a professor and exactly what professors should do. So huge congratulations to you, and thank you so much for coming to spread your wisdom with us in your reflection.
Thank you.